All right, this is for the unit 4 test. So let's see what we got. So starting off with number 1, says we have to multiply these and then state any restrictions on the variables. So when we want to multiply these two things together, first thing we want to do is try and factor everything to see if anything's going to cancel out. So that's what we're going to do first, is factor this part up here and this part down here. So 16 minus x squared, that's a difference of squareds. So a difference of squares means we're going to get 4 plus x. So again, the square root of 16 is 4. Square root of x squared is x. And 4 minus x. We have 8x from the second term, so we'll just put that in its own parentheses up here for right now. And then on the bottom, we've got the 4x, and then we want to factor this over here. But again, this is another special factor. This is just going to become x plus 4 and another x plus 4. So again, that's an a squared plus 2ab plus b squared. Again, square root of x squared is x, square root of 16 is 4, and then 8 divided by 2 equals 4. We'll say 8x divided by 2 equals 4x, and that is x times 4. So we don't really need to do any t-charts with any of those. Same deal up here. If you want to do them, you could. But the reason we do this is because now we can see things that are going to cancel out. So if we look, we've got a 4 plus x here, and x plus 4 is the same as 4 plus x, so those will cancel away. We have an x and an x, so those will cancel away also. And then right here, 4 and 8, well, 8 divided by 4 is going to be 2. So it turns out we're going to get 2, 4 minus x over x plus 4. And that's about it. So nothing else is going to cancel out. We can leave our answer like this. If you really wanted to, you could make them look a little nicer. You could factor out a negative sign and make it x minus 4 over x plus 4. But I'm pretty happy if you can get it to here. That shows that we've multiplied correctly. Next part B, says state any restrictions on the variables. Now this is where things get a little bit tricky because we can't use our answer. What we need to do is use our intermediate right here. And so we're going to take each of our parentheses and set them equal to 0. So 4x equals 0. So x is just going to be equal 0 if we divide both sides by 4. So x is not allowed to be 0. Over here, we've got x plus 4 equals 0. Subtract 4. X equals negative 4 won't work out, so x is not allowed to be negative 4. This is the same as the other one, so we could subtract 4 from both sides and get, x is negative 4. So x is not allowed to be negative 4. So again, remember the reasons that we can't do those, the reasons we can't pick those is because those would make the top expression be something divided by 0. And so we're not allowed to divide by 0, so we can't pick those ones. Any other value for x would be okay though. So that's it for number 1. All right, for number 2, we want to simplify. And then again, state any restrictions on the variables. So if we're going to simplify, we have 2 options. The fast way to do it, I'm going to do the fast way first, is we could recognize down here that 5 minus x is the same thing as negative x minus 5. Oops, I did not draw my x minus 5 very well. So we could turn this really quickly into 1 over x minus 5 plus negative 2 over x minus 5, which is negative 1 over x minus 5. So that would be the fastest way to do the question because now we're already done. We've simplified it. If you want to go kind of the longer way, but again, this way works no matter what. This one kind of uses a trick that x minus 5 and 5 minus x are the same, just with the negative sign factored out. What you could do is multiply by what's missing. So here we have an x minus 5 in the denominator. Here's a 5 minus x. This one does not have an x minus 5. Oops. So we have to multiply the top and the bottom by x minus 5. And here, this one's missing the 5 minus x. So 5 minus x. It's not a very good 5 minus x. And now we can just smush them together. So we can actually do 5 minus x times 1 plus 2 times x minus 5 all over 5 minus x times x minus 5. Because again, now we have a common denominator. And when we get our fractions, if we want to add fractions up, leave the denominator the same, add up the numerators. So we'll still have to do a little bit more work because we still need to actually see what we get on top. But we can see this 1 is going to distribute. And that's pretty quick. That's just going to be 5 minus x. 1 times 5 is 5. 1 times negative x is negative x. And then this 2 is also going to distribute. So plus 2x, 2 times negative 5 is 10, minus 10. Bottom, we keep the same. So 5 minus x, x minus 5. We don't really want to mess with the denominator because, again, we're hoping things will cancel out. And in this section, usually it's a little bit easier if we keep things like this for the most part, because then we can see where things are going to break. I still need to combine like terms. So I'm going to come over here and say I've got 5 and minus 10. And I've got, that's going to be negative 5. And then we've got minus x plus 2x is plus x over, and again, we still have the same denominator. Just keep that in black because we're not really doing anything with it. 5 minus x, x minus 5. Now again, we still need to recognize we want to put this in standard form. So if we put this in standard form, this is then going to become x minus 5. So x would go first, and then the number would go at the end. And then on the bottom, put this in parentheses, we've got 5 minus x and x minus 5. And we can see that these two x minus 5s would cancel out. So that leaves us with 1 over 5 minus x. Now, is that the same as this one? Yeah, it is, because if we factor out a negative sign, we would get negative 1, and then we'd switch the signs on the bottom. X minus 5. So it does work out. You can go either way. Again, this would also be an acceptable answer. That would be totally fine. Either one of these would work out. You can see this way was a lot faster just by recognizing this trick right away. If you don't recognize the trick, it is a little bit longer. And then for part B, we have to state any restrictions on the variables. So again, we need to go back to the original, or this one over here, and we're going to set each of the denominators equal to 0. So again, I could do that either from the original. So if I just want to use the trick, I can just come right over here and use the original one to solve it. If I don't use the trick, I can use this one over here. I'm going to use this one because there's a little bit more space to just write it. So here I'd have to add x to both sides to get 5 equals x. So x is not allowed to be 5. X minus 5 equals 0. We add 5 to both sides, and we get 5 again. So the only rule here is that x is not allowed to be 5. And again, that's because that would make the denominator 0, and you can't divide by 0. So that's why we have to do that. All right. Moving on to number 3. So number 3 says the variable p varies inversely with x. If p is equal to negative 2 when x equals 6, find the value of p when x equals negative 12. So first of all, we notice we've got the word inversely. So if p is going to vary inversely with x, that means we want to write the equation p times x is equal to k. All right, and just like before, our goal is we want to solve for what k is. So we know what p is negative 2. We know what x is 6. So negative 2 times 6 equals k, which means negative 12 equals k. So this gives us our equation, p times x equals negative 12. And now we want to sub in the second part, which is x now equals negative 12. So p times negative 12 equals negative 12. Divide both sides by negative 12. And we get p equals 1. And there we go. So that's our rule. So remember, because it says inversely, that's why we're using the one where we multiply them together, because we want them to multiply to a constant if they vary inversely. All right. Number 4, which one's model inverse variation? Select all that apply. So again, we're dealing with inverse variation. So we want things that are of the form x times y equals k. So it's really easy to pick these ones out. This one has x times y. This one has x times y. This one does not. X and y are on opposite sides, and if we tried to change that, we would end up with, y equals negative 6x. Divide both sides by x. We would get y divided by x. That's not what we want. Same deal over here, 20y equals x. If we try and get them on the same side, we would get 20y divided by x equals 1. We have y divided by x. That's not inverse variation. When you divide them like that, or when they're on opposite sides like that, that's direct variation. So that one's pretty quick. You just have to recognize this form. This is the key, is to remember that form for inverses. All right, number 5, what's the domain? Not too bad. So remember, for domain is always going to be all x except, EPT, where the denominator is 0. So x is not allowed to be some number where we would set this equal to 0. So that's our goal, is we have to solve that equation. And then again, we have to double check to make sure that it doesn't also make the top 0. So let's set this equal to 0 first. X to the 4th minus 81 equals 0. So we get x to the 4th equals 81. Oops, write them out. Add 81 to both sides. We can 4th root both sides to get x equals plus or minus 3. So again, since this is an even root, since I'm doing a 4th root, I do need the plus minus here again. So it looks like I'm going to pick plus and minus 3. But again, I got to double check. I got to make sure that neither of those makes the top equal to 0. Easiest way to do that is to factor the top. Find things that multiply to negative 2 and add up to negative 1. Well, things that multiply to negative 2 and add up to negative 1 would be negative 2 and 1, right? Since neither of those would give me 3, I know that I'm safe here. So I can just go ahead and write plus or minus 3. If I want to double check, again, I could plug them in if I wanted to. That would be a little bit longer. 9 minus 3 minus 2 is not 0, so I'm safe. 9 plus 3 minus 2 is not 0, so I'm safe. So you can do either one. You can either factor it, or you could plug it in. So again, we'd have to check both of them. 3 squared minus 3 minus 2. Negative 3 squared minus negative 3 minus 2. And these are not equal to 0, so they're safe. So we're good to go. All right, so that's what we get. Let me circle the answer just so we know what the answer would be. That's the answer. All right, for 6, identify the horizontal and vertical asymptotes for the graph of y equals x squared plus 4x plus 3 over 9 minus x squared. Again, not too bad. First thing we want to do is grab our horizontal asymptote. To get the horizontal asymptote, again, what we want to do is in our expression, look for the highest power of x. So in this case, squared is the highest power of x. I have a squared on the top and the bottom. So I have 1x squared is my highest on top. Negative 1x squared is the highest on the bottom. So negative 1 is equal to y is my horizontal asymptote. For the vertical asymptote, what we want to do is, just like we did with the last one for the domain, set the denominator equal to 0 and double check to make sure it doesn't make the top equal 0. So let's factor both the top and the bottom, just because it seems like that's going to be the easiest route on this one. So on top, I want to find things that multiply to 3 and add up to 4. That's x plus 3, x plus 1. On the bottom, I've got a difference of squares. So 9 minus x squared would be 3 minus x and 3 plus x. Okay, well, pretty clearly we can see two things that are going to cancel out. X plus 3 and 3 plus x are the same. So this is going to leave me with x plus 1 over, I may as well write this in standard form, negative x plus 3. Again, we can clearly see here we've got 1 divided by negative 1 is negative 1. So you can get the horizontal asymptote from there also. But to get the vertical asymptotes, we set the denominator equal to 0. So negative x plus 3 equals 0. Add x to both sides. 3 equals x. So x equals 3 is the vertical. It looks like negative 3 might also work if we had thought about it from the beginning, but we can see that's going to be a hole because it's going to cancel out. So that's what we get for number 6. For number 7, we've got a couple graphs. We have to sketch f of x and g of x, then identify points of intersection to 3 decimal points, and then how many points of intersection are there. All right, well, if we really wanted to, we probably could sketch these two without making a graph in Desmos. G of x is x squared. That's very nice because that's just our regular parabola. I mean, we could even draw in the points really quickly. 3, 9, like up here. And so g of x is pretty quick. There's no translations. There's no shifts or anything. F of x is our 1 over x equation, but we're going down 5. So remember, minus 5 is down 5. So our y, our horizontal asymptote would be down 5. Again, I'm a little bit in the way, but that's all right. And we know our 1 over x kind of has the shape of that. So we know we're going to look like this. But we got to find our other vertical asymptote at 0. Let's get that in quick. There we go. All right, so we're going to look like this. And we're also going to look like this. Looks like I'm in the way a little bit. Did I draw? Okay, good. Let's clean that up. All right, so we can see that we're intersecting just once here. But we do have to find the point of intersection to 3 decimal points. So we got our choice. We can either do it by hand or with the graphing calculator. Since the instructions say to 3 decimal points, I think that's a good sign that we just want to throw it into Desmos or our graphing calculator and just see where they cross. So let's do that. So we got 1 over x minus 5. And x squared was the other one. And so we can see that they do cross. They cross right here. And that's our point of intersection. If we want to zoom in a little bit, we can zoom in and see, yeah, they cross just right there. So pretty good. Oh, look at that. Desmos is now giving me 4. That's kind of cool. But 0.198. And then 0.0394, so 0.039. And there we go. And that's it. So that's what we got. All right. Other cool thing with this, if I zoom back out, let's go home. We can see that, yeah, our intercept, our horizontal asymptote is here at -5, because that looks like that's where they're both headed towards. Move that up, and they're both headed towards -5. Our vertical asymptote is right here at 0. Again, you can double check some of the other questions with the graph this way, since it does give you those asymptotes. All right. Number 8. So for 8, describe the transforms needed to translate the graph y equals 1 over x to the graph of y equals 2 plus 1 over x minus 5. Just real quick, I'm going to rewrite this so it looks a little bit nicer. X minus 5 plus 2. So I'm going to rewrite that. And now that's in the same form as our equation that was the y equals a over x minus h plus k. And so here, everything we just have to do is just match up the letters with the numbers, kind of like we've been doing all year. So since k is 2, we can say that we're going to go up 2. That's a shift. And we can see down here, h is 5. So we're going to go to the right 5 with a shift. That's it. So we're all done. Those are the 2 transforms. Again, if you want to graph them to double check, you're more than welcome to do so. Next, we got to solve these ones. So looks like it's a pretty big equation. So big thing we want to do is we actually don't want to add up the things that we have on the right-hand side. So a lot of people want to do that just because we think, okay, let's try and combine all the terms so it's a little bit easier. But the trick on this one is we actually want to try and factor everything. And that's a pretty normal thing to do whenever we've got these giant fraction expressions, is we always want to try and factor. So if we divide everything here by 2, because we can do a GCF on top, the bottom, again, we want to find things that multiply to 3 and add up to 4. I think that was on the review guide earlier as x plus 3, x plus 1. These ones we can't really do anything with. X plus 1 x plus 3. But we just want to play the game of what's missing. So we have to decide is from all of the denominators, we got to see what's missing from all of the denominators. So this one's got an x plus 3 and an x plus 1. This one has an x plus 1, but it's missing an x plus 3. So we have to multiply the top and the bottom by x plus 3. This one's got an x plus 3, but it's missing the x plus 1. So we got to multiply the top and the bottom by x plus 1. All right. Now, since all of these denominators are the same, they're all gone out of the problem. The only thing that we need to know from them is that from this one, x is not allowed to be negative 3. And from this one, oops, well, I can come back. All right, so we were right here. We found out that this one couldn't be negative 3, because again, that would make that equal to 0. Here, x is not allowed to be negative 1, because again, if we put negative 1 in here, then we would get 0 there. So what we got to do is then say all we got left is these numerators, so we just set the numerators equal to each other. A little odd, but we do want to redistribute this. Again, that just, if we factored it, if something canceled out, that would make our lives easier. It didn't, so we're back to 2x plus 4 though. We have to distribute this 1, so that's x plus 3. We have to distribute this 1. So 1 times x is x. 1 times 1 is 1. When we combine like terms, we get x plus x is 2x. 3 plus 1 is 4. And we can see that we get the same thing on both sides of the equation. So since we did that, turns out we're going to get infinite solutions. So since these are the exact same, the answer is going to be all real numbers or infinite solutions. But we have to remember we have two things we can't have. But x is not allowed to be negative 1 or negative 3. So it's infinite solutions, but not negative 1, nor is it negative 3, because those two, we already saw, wouldn't work out. They would make the denominators equal to 0. All right. Number 9, we have the robots. They can do a task in 5 minutes when they work together. The first robot, if it's alone, can do it in 15 minutes. How many minutes does it take the second robot to do it if the second robot were to do it alone? So when we have these time questions, we want to remember that their together time is equal to the first one and the second one, but we want to take the inverse of all of them. So the time it takes both of them to do it is 5 minutes, so 1 over 5. The time it takes the first one to do it is 15 minutes, so 1 over 15. And we don't know the other one, so we'll just call that one x. All right, so this is the equation that we have to solve. May as well just make these all common denominators, so it looks like we're working mainly with numbers. So we're going to get 3/15. Well, we can't do that yet. I forgot we have the x there. The x is a problem, so we have to do what we normally do. Play what's missing. All right, so again, if we want to go the lazy way, we just say, well, 5 is missing both 15 and an x. So we'll multiply by 15x. 15 is just missing x and the 5. Oops. Yep. So we got 5x, 5x. And then x is missing both the 15 and the 5. So 5 times 15, 5 times 15. All right, so this is going to give me all the denominators again. They all cancel out, which is nice. So 15x times 1 is 15x. This is 5x times 1 is 5x. And then 1 times 5 times 15 is 75. All right, so this is a normal equation to solve. Subtract 5x from both sides. So 10x equals 75. Divide both sides by 10, and x equals 7.5 minutes. So there we go. If you noticed, we might have been able to do this one with a little bit smaller numbers. Again, if we had the 1 over 5 equals 1 over 15 plus 1 over x, we might see that the common denominator, we don't have to multiply by 15. We could just multiply by 3. Well, x as well, because 3 times 5 would be 15. Then this is only missing an x. This is still missing a 15. But we can see our numbers are a little bit smaller here. We get 3x equals x plus 15. Same idea, though. We cancel out all the denominators because they're all 15x. Our numbers are a little smaller. 2x equals 15. We're still going to divide, and we're still going to get 7.5. So we could do it either way. It doesn't really matter. Again, this way always works and requires no thinking. This way requires a little bit of thinking, but you get smaller numbers. So it kind of harkens all the way back to Algebra 1. If you remember the linear combinations where you had to decide what to multiply the top equation and the bottom equation by. It's kind of a similar idea. All right, for number 11, we've got a nice equation to solve. Not much to do but to solve it. So let's get our common denominators. So we've got 3x, and again, we can just play what's missing again. So in this case, this is over 1, so we're not really missing anything with 3x. So that one's already set. I don't need to do anything on that side. This one is missing 3x, so I have to multiply both sides by 3x. And then this is an x, so we're missing 3. All right, so again, denominators are all going to cancel out. The one thing we want to remember is that x is not allowed to be 0 in this case, since we want to set the denominator equal to 0 to see what number we're not allowed to get. So if we get 0, again, we got to get rid of that because it's an extraneous solution. All right, well, we're going to distribute this 2. So this is a lot like number 9. So 2 minus 2x. 1 times 3x is 3x. 3 times 3 is 9. And then this is a regular algebra 1 equation. So x is on one side, numbers on the other. So let's add 2x to both sides. So 2 equals 5x minus 9. Let's add 9 to both sides. 11 equals 5x. Let's divide both sides by 5. 11 divided by 5 would be 2.2 for x. Since 2.2 is not 0, we're safe. We're good to go. And that's it with 11. So we're good to go on 11. Number 12, it says find the quotient. So we want to remember quotient means we're going to divide of these two giant rational expressions. And then part B says state any restrictions on the variables. So we have a lot of work to do on this one. We just have to be really careful about it. So since we're going to do a quotient, anytime we want to do a quotient or we want to multiply, first thing we want to do is factor everything that we can. Because again, when we factor things, a lot of times things will cancel out. It'll look a little bit nicer. So since we're doing a quotient, we're doing division. So let's factor. X squared minus 16 is x plus 4, x minus 4. So we got our squares, difference of squares. X squared minus 10x plus 25 is another a squared minus 2ab plus b squared. So x minus 5 times another x minus 5. All right, we're doing the quotient, so we're going to divide. 3x minus 12 has a GCF. We can take a 3 out of both x and 12. We'll get 3x divided by 3 is x. 12 divided by 3 is negative 4. And then this one we can factor. We think what multiplies the negative 10 adds up to negative 3. That's negative 5 and positive 2. All right. So this is our first tricky point, is we can see we got a whole bunch of denominators. We got a whole bunch of factors. Let's find out what x is not allowed to be, because we have to state all the restrictions on the variables. So from this one, again, we're going to do x minus 5 equals 0. Add 5, so x equals 5. So x is not allowed to be 5. Since this is the same, I'm going to skip it. This one's also the same, so I'm going to skip it. X plus 2, though, is different. So x plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. X is not allowed to be negative 2. All right, so far, not too bad. Kind of looks like some things we've done before. Again, you just have to remember to factor cleanly. Now we have to actually do the division. So now we need to remember the division rule. So for the division rule, we want to multiply by the reciprocal. So now this is going to become x plus 4, x minus 4 over x minus 5, x minus 5, and we flip the second fraction. X minus 5, x plus 2, 3, x minus 4. Now this is where things get tricky, and that's we have a new denominator here. So we got to do the same thing we did over here and get rid of anything that would give us 0. Oops, purple. So we have a new option we have to get rid of, because now this x minus 4 pops up. So x minus 4 equals 0, add 4 to both sides. X is not allowed to be 4 either. All right, well, I'm done doing all of the denominators. I'm not going to get any new denominators. So I can pick my answer for B at this point. But I'm still not done with part A. I still have to actually multiply these things. But the nice thing is, remember, when we multiply them, we don't actually multiply anything out. What we want to do is just find out what cancels and then write what's left over. So if I search x plus 4, there's no x plus 4, so that stays. X minus 4 and x minus 4 cancel out. X minus 5 and x minus 5, I could cancel out either one. I'm just going to take out the first one. And I got x plus 2. So what was left over? Well, what's left over is x plus 4, x plus 2. I like my 3 out front, so I'm going to put the 3 out front, and x minus 5. So again, the cool thing is we don't actually need to multiply any of this together for this section. If you really want to, you can distribute the 3, and you can double distribute the x plus 4 and the x plus 2. Not necessary at all for this question, but if you really wanted to go through that and do some extra work, you can do that for some extra practice. This is what the answer would be, and these are our variables. So it's a little bit weird that we get 3, but we get this one hidden one when we actually do the multiplication, when we flip the fraction. So kind of cool. The reason that happens is, again, if we picked 5, obviously this one's going to be 0. If we pick negative 2, we would be dividing by something and something divided by 0. So we wouldn't have anything that exists here. Once we flip it, if this were now 0, then we would be dividing by 0. We'd be dividing the whole fraction by 0. So kind of cool, but that's number 12. For 13, find the slope of the line joining the points whose coordinates are a, comma 1 over b, and b, comma 1 over a. So this is our regular slope equation. M equals y2 minus y1 over x2 minus x1. Nothing really too crazy here. This is just going to be x1, y1, x2, y2. So we get 1 over a minus 1 over b over b minus a. Okay, so this is the slope. Looks kind of ugly, but we do have to clean it up a little bit. And that is, we can actually subtract the top. So to do this, what we want to do is get common denominators. This is missing the b. This is missing the a. So our slope is going to become b minus a over ab divided by b minus a. All right. Well, since we're dividing, we have to remember that could be the same thing as saying, well, let's do b minus a over ab divided by b minus a. So that's b minus a divided by ab. And then since we're dividing, remember the rule for dividing is you multiply by the reciprocal. So 1 over b minus a. And now we can see these two b minus a's cancel out. So we get 1 over ab. And that's our result. So kind of fun. So it starts out with something that was simple, that we're really familiar with, the regular slope formula, y2 minus y1 over x2 minus x1. And we get to do some fun fraction operations in order to get one nice clean expression, 1 over ab. So pretty cool. All right, for 14, we have to solve. So we have x equals 2x squared plus x minus 7 over 2x plus 8. First thing we're going to do is see what we're not allowed to have. Not allowed to have this to be 0. So 2x plus 8 equals 0. So 2x equals negative 8 over 2. X is not allowed to be negative 4. So if I get negative 4, I have to get rid of that. That's an extraneous solution. So how do we actually solve this one? Well, just like with SOHCAHTOA problems and all those things from geometry last year, just put this over 1 and then cross multiply. So we're just going to cross multiply here. So we get x times 2x plus 8 equals 2x squared plus x minus 7. We can distribute this x to both pieces. 2x squared plus 8x equals 2x squared plus x minus 7. And now it's a regular one. So since we see we have the squared, we might think we want to get everything on the same side, but if we subtract 2x squared from both sides, that actually drops out. So kind of cool. So we actually end up with 8x equals x minus 7. We can subtract x from both sides to get 7x equals negative 7. Divide both sides by 7, and x is negative 1. Negative 1 is not negative 4. So again, we're safe. We're good to go. So that's what we got for that one. Again, the reason I didn't factor this one, I looked at it and I said, well, 7 times 2 would be 14. I don't know anything that multiplies to 14 and adds to 1. If I did, I would have factored it, but I didn't, so I didn't factor it. But a good idea to check to see if you can factor it. I just didn't say that at the beginning. But yeah, that's why I didn't try and factor it to try and cancel anything out. All right, 15, identify the horizontal and vertical asymptotes of this graph. So again, I can see I've got this x plus 1 squared. This does look like it's going to factor, so unlike the last one, I am going to factor it. This x plus 1 squared is x plus 1 times another x plus 1. X squared minus 3x minus 4, so we think what multiplies to negative 4 adds to negative 3. That's going to be x minus 4 and x plus 1. So this is kind of cool. We can see these x plus 1s are going to cancel. So we get y equals x plus 1 over x minus 4. All right, so for the horizontal asymptote then, let's stick with the blue. We can see we've got x and x, so x divided by x is equal to 1. This is my horizontal. For my vertical asymptote, again, I want to set this equal to 0. X minus 4 equals 0. Add 4 to both sides. So x is 4, so x equals 4 is the vertical. All right, well, I think we've had that question before on the thing, so we're just doing that again. Again, a couple of the questions will be very similar. So with this one, pretty similar to, I think, maybe like number 2 or number 3, something pretty early in the review guide. So that's 15 now. For number 16, it takes 4 hours for faucet A to fill the tank, and faucet B is 6 hours. How many hours does it take to do them together? So again, this is another repeater, because this is going to be the same equation we had before. 1 over t of both is equal to 1 over t1 plus 1 over t2. The difference here is this time the x is going to go for the t both, because we have to find out how long it takes to fill them together. So 1 over 4 plus 1 over 6. And we don't need to mess with everything that we did in the last question, because we really just need to solve the right-hand side. 1 over x can just stay as 1 over x. So 1 over x, if I get these to be a common denominator, this would be 3/12 plus 2/12. So 1 over x equals 5/12. And we know that if we've got 1 over x and 5 over 12, if I want to get x, I just flip both of them. So that tells me that x equals 12 over 5. If I want to write that as a number of hours, so 2.4, I take 12 over 5 though. 2.4 would also count. We could actually divide if we wanted to. All right. Cool. 17, a graph of xy equals 6 is translated up 2 units and left 2 units. Which are possible equations for the translated graph? Select all that apply. So with our transform up 2 units, this means that our k is going to be equal to 2, or we're going to have a horizontal at k equals 2 at 2. If we're going to the left 2 units, again, this means that h is going to be negative 2, or we know that we're going to need to have a vertical at negative 2. So what we want to do is pick all of these that apply. So the ones that look good are going to be A, C, and D because they're already in y equals. So those ones are going to be the easy ones to check. So with this one, I mean, this one's perfect. I got a 2 out front. I got x plus 2, which means I'm going to go left 2. So A looks perfect. We're just going to pick that one right away. With this one, the left 2 seems reasonable. We got x plus 2, but we got to check for the k. So with this one, instead of looking out front, again, we also want to interpret this as a horizontal asymptote. So if I've got 2x over 1x, that's 2x over x, because x is the highest degree on each of them. Well, overall, x is the highest degree. And that is 2, so that does check. That does follow. That works out. This one, we have x minus 2, so this one's out. D is a poor choice. For B, we do have a little bit of work because we want to make sure we get it to be a y equals. So I need to multiply both sides by 2. So we get y equals 2 times x is 2x, 2 times 5 is 10, and x plus 2 on the bottom. And then you might say, well, wait a second, didn't we already answer this question? Yeah, it's the exact same expression as C, because B and C are literally the same thing. So we're going to pick B because we already picked C. But if you want, you could run through the whole process. 2x over x equals 2. Yes. X plus 2 is h is negative 2 or a vertical asymptote at negative 2. So that's 17. Kind of fun. This one's kind of nifty that you get the little 2 down here. For 18, we're given that a is 2 over x plus 1 over y. What is 1 over a? So the heart of this question is going to be like the one that we just did with the faucets, where the goal is to get one expression and then just flip them both. So let's get one expression over here, and then we're going to flip each of the expressions. So to get a common denominator here, we're missing a y. To get a common denominator here, we're missing an x. So a is equal to 2y plus x over xy. Well, now I just flip them both, make the flip. So 1 over a is equal to, oh, I got to pause again. So if we want to flip it, since we've got a, we can do 1 over a. We can just flip the other one to get xy over 2y plus x. And that's it. So, I mean, that's a pretty quick one. As long as you know what you're doing, as long as you remember the idea is to just get the a and then flip it, it's a pretty quick one. So that's it with 18. So for number 19, again, identify the horizontal and vertical asymptotes. Seems like a pretty quick one. For our horizontal asymptote, we're going to look at the x's. Since x is just the highest degree of x, we get negative x over x is negative 1. So I probably should put that over there. Let's just transport that all over. And that's going to be my horizontal is negative 1 equals y. Is the horizontal asymptote. So we still need to get the vertical one. To get the vertical one, we set this equal to 0. X minus 8 equals 0. Add 8 to both sides. X equals 8. So x equals 8 is the vertical. And that's it. So that one's already done too. So again, since we've done a few of those already, 19 went by pretty quickly. For number 20, we have another solve. So again, this one looks kind of complicated, but we want to think about this and say, well, wait, we're just going to play what's missing. So if we look at our expressions, we have x minus 2 in the denominator. X minus 2 in the denominator, 1 is in the denominator. So really the only thing I need to do is multiply this middle one right here by x minus 2. And again, when we multiply that by x minus 2, all of our denominators are the same, so they cancel out. X minus 2 equals 0. X is not going to be allowed to be 2. So 2 is our extraneous solution if we get it. Now we're just working at the tops. We get x squared plus x minus 4. X times x is x squared. X times minus 2 is minus 2x. And then minus 1. So again, it looks like we may have to do a quadratic, but when we decide to subtract x squared from both sides, the x squareds cancel out, and we get x minus 4 equals negative 2x minus 1. We can add 2x to both sides. 3x minus 4 equals negative 1. We can add 4 to both sides. 3x equals 3. We can divide both sides by 3. X equals 1. 1 is not the same as 2. So again, that one checks out. It's not an extraneous solution, so we're good to go. So that's what we get for number 20. All right, for number 21, which graphs have a horizontal asymptote at y equals 2/3? Select all that apply. So that doesn't seem like that's going to be too bad. Again, here we see x is the highest degree we have, but there's no x's on top. So this is actually going to be 0x's divided by 3x's is 0. 0 is not 2/3, so we're not going to pick A. Here, x squared is the highest, so we have 2x squared over 3x squared, which is 2 over 3, because the x squareds would cancel out, so that's good. This one is a little bit strange, but this one's actually in the form of A over x minus h plus k. They just have the k out front. And since k is 2/3, we actually can pick C. So that one's a little bit strange, but it's pretty cool that we get to kind of have to think about this two different ways. For D, x squared is the highest, so oops, not 2x, because there's no x squareds on top. Since there's no x squareds on top, that 0x squareds divided by 3x squareds is going to be 0, just like for part A. So we're going to get rid of choice D. And that's it. That's what we got for 21. All right, last question to do is 22. 22 is a little bit strange because it is a review one from the last unit. A rectangle has an area of this expression and a width of this expression, and what's the length in centimeters. So if we remember that area is length times width, and we're given the area and the width, if I divide both sides by the width, A divided by W equals L. So what we have to do is divide this one, x cubed minus 15x minus 4 by x minus 4. But if we're just dividing two expressions, what we're really doing is just synthetic division. So we have 1x cubed, no x squareds, minus 15x's, and minus 4. So this is going to be 1. 1 times 4 is 4. Add them up, we get 4. 4 times 4 is 16. Add them up, we get 1. 4 times 1 is 4. We get 0, which is good, because if we didn't get 0, that would mean that our length and our width don't multiply to each other. Final answer then, since we started with the 3, this is going to be a 2, so x squared, go down the line, 4x's, then no x's, and that's it. So that's what we get for number 22. Pretty quick. You just have to remember that that one is a review one, not exactly from this section. All right. Before I cut the video off, I do want to go over just quick, okay, let's say I finished the test. How do I check all of my answers? Maybe not all of them, but some of our answers. So I want to go through and show you how you can use the calculator to double check a few of the answers. So multiply, we're probably not going to do too much there. Again, you can multiply, you can graph your initial, graph your answer, see if they line up. Same do a simplify. Graph the initial, graph your answer, see if they line up. This one, can't really do too much with it. Inverse variation, can't really do too much with it. Domain, we actually can. So this one's kind of cool. If we type this into the graphing calculator, so let's put that in, 1, negative 1, negative 2. And it was x to the 4th over 80, minus 81. You can actually see, because our domain should never include the vertical asymptotes. So we can see right here, yeah, negative 3 and 3 are going to be where those asymptotes are. And yeah, negative 3 and 3 are the only places where our graph doesn't exist on the x. So kind of cool. We can actually check that one. Identify the horizontal and vertical asymptotes of this one. We got 1, 4, 3. 4, 3. And this was 9 minus x squared. All right. And again, we can see here, oh, okay. So yeah, it looks like we're right here at 3. Let me go back home real quick. Yeah, it looks like that's where this is at. This line right here is at 3. And if we check our answer, yeah, we got our vertical asymptote at 3. We have a horizontal at negative 1. If we zoom out a little bit, yeah, it looks like that's at negative 1. It looks like that's where we're headed to on both sides, so that matches up. So again, we can use the graph just to double check, just to see what it looks like, scope out the idea. We did this one in the graph already since we kind of had to get our decimal points, so that's pretty good. Identify the transforms needed. Again, if I want to double check, I'm going to put in 1 over x. Parent function. And child function was 2 plus 1 over x minus 5. And so again, what we want to do is think about where the center point ends up going. It's kind of hard because it's not actually on the graph. We have to kind of imagine that we're going to go over 5 and up 2. Is that what we got? Right, 5 and up 2. So that makes sense. If we want to solve this, again, if we have to solve it graphically, we got to put in one side on one line, other side on the other line. So 2x plus 4. And let's actually get that in first. 2x plus 4. I think this was x squared plus 3x plus 4. 4x plus 3. All right. And then for the other one, we have x plus 1 and x plus 3. We can see that they line up perfectly, so that's a good sign that it's going to be all real numbers, except, again, we can look at see where these asymptotes are. So we got one at -1 here, and then one at -3 there. So again, just double checking them. Okay, yep, that makes sense. Moving on. With the robot, can't really do too much again. Here we've got another solve, so we can do this one just like we did the last one. If we want to put in 2 parentheses 1 minus x, and we're dividing by 3x. And on the other one, we've got 1 minus 3 over x. And we can see that these things are going to line up right here at 2.2. That's what we got for our answer. The other cool thing about this one is you can see the vertical asymptote at 0. And again, that was our one value that we said we weren't allowed to have. So it does show up on the graph too, which is pretty cool. Oops, that's the next one. Find the quotient. Again, not too much you can do there. You do have to actually, you could plug in the initial division and then your answer, but again, that seems like a lot of work. Find the slope, not much you can do there. Another solve. So again, if we wanted to, we could check this one. We've got x and then a big expression after x. Side's easy to type in. That's pretty nice. So x and then 2x squared plus x minus 7. And that's going to all be divided by 2x plus 8. Again, if we see where these things connect, it does look like they only connect once, and they connect down here at x equals -1. So we got x equals -1. X is not allowed to be -4. We can see, yeah, it looks like we got this asymptote here at -4. Let's zoom out a little bit more. Oh, there's the rest of it. So, yep, that looks like that's at -4. So again, looks pretty good. Sometimes you got to zoom out to see the whole thing. Cool. Oops, 0 key. I want to type 0 in there. All right, 15, identify the horizontal and vertical asymptotes. If we want, we can check. We can type this in, x plus 1 squared. Don't need that one now. X plus 1 squared. Is this like x minus 4 maybe? I kind of forget what was down there. X squared minus 3x minus 4. Okay. All right. And so again, we can kind of see what we got going on for our asymptotes. If I actually type it in right, there we go. Again, we can see it looks like we got our vertical asymptote here at 4. and our horizontal asymptote right here at 1. We can zoom out to make it a little bit clearer, but yeah, you can visually double check it on the graph. Faucets are fine. Same deal here. If we want to check which are possible equations for the translated graph, if we want to check one of them, like let's check out A, we can put in xy equals 6. We should probably put in y equals 6 divided by x. It'll be a little bit nicer. And then you can put that into the TIs as well. 6 divided by x. So we get a y equals equation real quick, just like we did with this one down here. 2 plus 6 over x plus 2. And then we can see again, you have to kind of visualize the center. So it does take a little bit of effort, but yeah, we're going to the left and then we're going up. And that's kind of where the new center is between these two. So yeah, that looks like that checks out. Whoops, wrong button. If I want to check out the other ones, since B and C ended up being the same, I'm just going to put in 2x plus 10 over x plus 2. 10, x plus 2. And yeah, we can see that's in the same spot. So same thing. 18, just have to do that one by hand. 19, negative x plus 3 over x minus 8. X plus 3 or x minus 8 or plus 8. Minus 8. Let's get this one off the screen. We're good. Not good. So we're going. Oh, looks like my browser crashed though. All right. Well, anyways, we can kind of see we got the purple one right there. It's kind of hard to see, but yeah, we got 8, and that's at negative 1. Kind of matches up. Oh, my browser's back. Yeah, so x equals 8 right here, and then y equals negative 1. So we end up with same things that we got when we did it by hand. For number 20, if we want to solve it, and just like the other one that we solved like this, we got to go left side and then right side. So x squared plus x. Rest minus 4 over x minus 2. All right, pretty cool looking graph. But again, we can see that we don't want this answer right here because the equation doesn't exist there. Other side is x minus 1 over x minus 2. X minus 1 over x minus 2. There we go. And again, we can see, yep, those two asymptotes definitely line up, but our intersection's here at 1. That's what we get. We get x equals 1. We also see the vertical asymptote, so we know that x should not be 2. Which graphs have the horizontal asymptotes at 2/3? So this is another one where if we wanted to type them in, we could. Let's type in A because A doesn't work. 2 over 3 x minus 1. You can see the asymptote is at 0. That's what we calculated that to be. 0 is not 2/3. So that's how you can tell. You can check each of the choices that way. I'm not going to type all of them in, but that's what you would do is just check them all. But you can see we do end up with the same answer that we got here. And then lastly, with the synthetic division, you just want to do that one by hand. So again, just kind of quickly ran through how to do some of them just to double check yourself with the calculator. In case you're a little bit unsure of some of the answers, or in case you want to use the calculator on the test to kind of give you that little boost of confidence to say, yeah, I got the right answer.